So this question is usual. Some people will face some issue with this question. Most of the time is on is in part B that they face the problem. So for part the first part B, C, most students are okay with it. So it's a horizontal beam which form the structure of the roof. Okay, so they give all the dimension. So this is not a three-dimensional diagram. It's just a structure of the roof. Okay, they didn't mention anything horizontal. They didn't mention anything vertical. Okay, so if you look at the diagram on its own, like no need to visualize as a 3D diagram. So with the information, I'm sure you can find this angles on the straight line. So do account for it. And because of angle on the straight line, you can actually get angle sum of triangle. So that should help you to find BC. So BC should be able to find it by sine rule. So part A, you should be able to use sine rule. So give it a try, make sure you can get the answer. Okay, so the second part is the one that's confusing. So the second part is the one that's confusing. Okay, they are going to add an extra beam to be added at M. And to the M is actually the midpoint of CD. So it's a bit of English. So they are describing where is M. So M is the midpoint of CD. That means the 2.62 has already been divided into half. And then we're going to connect. The beam is going to be connected to N. N is going to be sitting on DB. So where is DB? Somewhere here. So my N will be somewhere along here. So they actually create two situations because it's an if question. So they create two situations. So part one, MN is perpendicular to DB. So B part one, MN is perpendicular to DB. So it's going to be perpendicular like this. So I'm going to draw it properly for you so that it's easier for you to visualize. So I'm going to enlarge the section on DM. So DM is half of 2.62. So that's 1.31. And then I'm going to make N perpendicular. So I'm going to drop M. So this is N. The means it's connected, is here. So MN is actually perpendicular to DB. So of course the 56 will still be there. So you are asked to find MN. So because of the perpendicular, you can just do a normal trigo. So in this case, you'll be doing a normal trigo like sine 56 MN over 1.31. Okay, now the second situation is different. The second situation, they actually make it parallel. So if you look, the second situation, they are going to make MN parallel to BC. So it will be structured in such a way, N is here, so that they could be parallel. And again, your job is to find MN. So I'm going to narrow down into this triangle. So I'm going to draw my triangle here. So my MD will still be there. It will still be 1.31. So my N will be here so that it can be parallel to DB. So what's the effect of parallel? So just now there was a 72, remember? So there was a 72 here. So just now there was a 72 here. So this will be also a 72. The property of a parallel line. So this one is corresponding angle. So just now we also have a 56. So that will be a 56. So we are interested to find MN. So I got to be using sine rule. So they are testing you on two situations. The two situation mainly is a right angle situation and non-right angle situation. So in non-right angle, you will approach it with sine or cosine rule, depends on the information. If it's a 90 degree, you approach it by a normal trigo. Then we come to the last part. The last part, we want the shortest beam from D to AC. So when you see the instruction shortest, it has to be perpendicular. And don't get misled. The 124 is not going to cut exactly into half. It will not cut exactly into half. So to find the shortest distance, usually there will be two methods. Okay, so one of the method will be you look for angles. Let's say, do you have this or do you have this? Because if you got either side, you can do a normal trigo just to find the shortest distance. Okay, so but if it's not available, then we will do by the area method. So I'm going to do by the area method. So this is the shortest distance. I'm going to let the shortest distance be K. So I'm going to formulate an area half done base sum height. So for part C, I'm going to formulate the area. Area of triangle ADC. So I'm going to do a half done base sum height. My height is the shortest distance. So that is my area. Well, another area that I could have gotten, right, will be I'm using the 124. I'm going to do the half AB sine C. So it's the same triangle. I can do a half AB sine C. So that will be half 3.93, 2.62, and sine 124. So you punch it out, you will get a value. So the idea here is these two will be the same value because we are talking about the same triangle, just that we're using different method. So if you use 2.91K equal to half AB sine C, you can divide to find K. So the area method is always half done based on height versus half AB sine C. And this will be the required part that you will need when they always ask you for greatest angle of elevation. Okay, so this one is necessary. They will always ask you for shortest distance and always indicate perpendicular distance. So just a recap, two methods. Either you use this area method, half AB sine C versus half done based on height, or you use the normal trigo if you happen to have some angles that allow you to use, like for example, this one. If I got this right, I can do a trigo. Okay. But don't assume that it will cut the length into half, or don't assume that it will cut the angle into half. It's not going to happen unless it's in a situation of a right isosceles triangle. Okay, so do try out this whole question. Make sure you get the answer.